So this is the nomenclature 3 slide, or chapter, something like that. So for here, we're going to be talking about the nomenclature specifically is for the is for chiral centers, which we dealt with in chapter 5, and then also with alkenes, which we started working with in chapter 4. So there's some very specific ways of naming these compounds. Okay, so the first one we're going to talk about are the chiral centers we were introduced to in chapter 5. Okay, so there's actually going to be what we say is we look at each individual chiral center and we give it a name. It's either going to be R or S. R actually stands for rectum, or something like that, which is the Latin for right, or S, which is which stands for sinister, which is the Latin for left, right? So like that. So they, so for a long time, being on the left was considered to be bad, right? So like that. So that was the old stories about people getting beat. People who were left-handed getting beaten to be, they thought there was something wrong with them, stuff like that. So to make them right-handed, okay, stuff like that. So stuff like that. But we're going to use this R and an S designation. Okay, so by that, so in order to be able to do this, okay, we have to see how the four groups rotate in space. Okay, and so what we have to do is we have to give them what are called priorities. Okay, so the higher the priority, we're going to look at 1, 2, 3, 4, stuff like that. So the highest priority to the lowest. Okay, and so we're going to use these what are called the Kohn-Engel-Prelog rules. Okay, so there was in the early part of the 20th century there was some competing, sort of ways of doing this, and it turns out that this was the group that their rules won. Okay, and so what you need to do is you start from where, say it's a carbon group, a chiral carbon, right? You look at the 4 individual atoms that are hanging off of that chiral center. Okay, so and so you rank them in terms of, in theory, it's atomic number. Okay, but in reality, what ends up being is it's the weight. Okay, because weight, if the same atomic number, you have a heavier isotope, that's going to win. But in practical terms, it ends up being the heavier it is, the higher the priority. Okay, so bromine is going to have a higher priority than phosphorus because bromine is heavier. Okay, nitrogen is going to have a higher priority than carbon. Okay, because nitrogen is heavier. And then for here, when you get the isotopes, you have 2 different hydrogens, right? So you have regular hydrogen, which doesn't have it, which has no neutrons, and then it's heavy isotope deuterium, which has a neutron. Okay, so it's going to have a molecular mass of 2. So even though it's this, they're both hydrogens, the deuterium, the heavy hydrogen is going to win. Okay, stuff like that. And so if the decision cannot be made for the so if there's a tie essentially for the 4 atoms that are hanging off of that chiral center, then what you do is you start looking at the bonds. Okay, so by that, and you take a look at the heaviest bond is going to win. Okay, so that if it's the same weight, okay, then you look at the number of them. Okay, so if you have, so let's say you look at this. So if you're looking at that chiral center there, okay, versus, okay, so we're interested in let's say that this is a tie. Okay, so with that, so what we do is we say, okay, we're going to look at we're going to look at that versus that. So this is the chiral center. Okay, this one has 1 carbon-carbon bond, okay, and 3 carbon-hydrogen bonds. Okay, this group here, so this has 2 carbon-carbon bonds, right? So this one and that one, and 2 carbon-hydrogen bonds. Okay, now the priority, right? So we look at the bond, the heaviest bonds first, and so it's still a tie. So 2 carbon-carbon bonds versus 1. Okay, but carbon-carbon is carbon, but this one has 1 of them. This has 2. Okay, so that means that this group here has a higher priority. So let's say that's 1 and that's 2. That's going to have a higher priority than this because even though the heaviest bond is still carbon-carbon, this one is going to be this one has more than this one here. So let's say we looked at let's say we looked at this one. Okay. Now for here, right, so here's the chiral center, right? We're going to look at, say, here versus here, right? So, right, they both have 1 right? This one has one carbon-carbon bond, right? It has one carbon-chlorine bond and then two carbon-hydrogen bonds. This one has two carbon-carbon bonds, right, here and here. This one has two carbon hydrogens. Okay. Now, first thing you got to look at is the heaviest bond. So here it's carbon-carbon. This one is carbon-chlorine. This one is heavier, so this one wins. Okay. It doesn't matter that this one's got one. You know, it doesn't matter. This has two carbon-carbon. This only has one. It doesn't matter. This one has the heaviest bond. That's the first thing you got to look at. Okay. And so, if there's still a tie here, what you do is you then go out one further. Okay, and then you keep radiating out until you find a difference. As soon as you find a difference, you stop. Set the priority, and then you're done. Okay, and so it doesn't matter what's going off on down the rest of the molecule, okay, or rest of that chain or whatever it is. So for that, as soon as you start from where that chiral center is, and you start working your way out. You start working your way out. If there's a tie, you go out here. You got one further on either side. If there's still a tie, you keep going out. Okay, until you find a difference. Okay, stuff like that. And so you can look at these for multiple bonds, right? So it doesn't matter if it's a double bond, right? Stuff like that. So if you have, so if here's your chiral center here, you have this group here, right? We're going to say that one here, right? It would have two carbon-carbon bonds, right? And two carbon-oxygen bonds, right? So 1, 2. Okay. If you look at the bonds, then you don't have to worry about the carbon oxygen, sort of the multiple bonds, where just look at the bonds themselves and then be done, you're good to go. Okay, and stuff like that. So again, you look at the atoms first. If there's a tie, then you look at the bonds. Okay, stuff like that. And then if not, if there's still a tie there, then you go one further out. Are the atoms the same? Yes. There's a tie there. Then you look at bonds. Okay, and the heaviest bond is the first is the higher priority. If it's tie there, is it going to be the same quantity? If there is, then you move on. Okay, if there's a difference in the quantity, then you move forward. But the first thing you look at is the heaviest bond. Like that. So, okay. So like here. Okay, it's kind of hard to see. So here, right, they're both CH2s, right? So they both have two carbon-carbon, two carbon hydrogens. So then we're going to move out to on this side, right? So here you have one carbon-carbon, this should actually say 3 carbon hydrogen. Here you got 2 carbon hydrogen, 1 carbon-carbon, one carbon chlorine, and that makes this side win. Okay. Okay, so once you have the priorities 1, 2, 3, 4, okay, you set those. There's 2 different ways that you could do this. Most professors like do it the steering wheel method. I'll talk about another one this is the way I learned how to do it. And I think it's a little bit, but there's pros and cons of both. Okay, so it turns out that here, let me turn that down. This looks a little bit like it's difficult to see. There you go. Now you can see this a little bit. You can see the slides a little better. Okay, so it turns out that what you need to do, if you're going to do the steering wheel method, what you need to do is you need to be able to rotate. Of course, now you can't see. You need to be able to rotate the molecule in space so that the number 4 is in a dash. Okay, so if it's like this, like if there's your lowest priority, you need to be able to rotate it in space so that the 4 is going away from you. Okay, and then you count 1, 2, 3, 4 around. If it's clockwise, it's R. If it's counterclockwise, right, it's sinister. It's S. Okay, it's something wrong with it. It's sinister. Okay, so you look at with 4 going behind, has to be going behind. Then you look at either clockwise or counterclockwise. You count 1, 2, 3, 4 around. Okay, it's just like for a steering wheel method, right? If you want to go right, you turn the clockwise. If you want to take your car right, you turn the wheel right. If you want to turn left, if you want to go left, you turn it counterclockwise, right? So that's how you do it. But the key is the 4 has got to be in the back. If it's not, you have to rotate it, and that's where your model kit will come into play, because it is difficult to be able to rotate it in space. I'm not always the best at it either. Okay, but you can take the molecule, and even if you just have a regular tetrahedron with, say, with 3 different colored balls on it, okay, you can rotate this and see how the atoms end up. Okay, so then you don't get confused. As long as you remember which one is which, you're good. Okay, stuff like that. So the other way that you can do this, and this is actually how I was taught, is to say, okay, your thumb is going to point towards 4. Okay, so in this case, let's say this is 1, 2, 3, and then 4 is coming out at you. Okay. Okay. What I'm going to do is I'm going to say your thumb points towards 4. Okay, so here it goes 1, 2, 3, right? What you're going to want to do is you're going to take your fingers, okay, with your thumb here, okay, and then rotate your fingertips from 1 to 2 to 3 with with your thumb pointing to wherever 4 is. Okay, so if 1 is over here, right, you're going to start your fingertips here and try to rotate around like this. Okay, as you can sort of rotate your hand around. So 1 to 2 to 3, like this. Notice how this I'm doing with my right hand, okay, with my thumb pointing up, right? So the 4 is pointing up at you, okay, so your thumb has to be this. If I were to try to do it with my left hand, right, it would be 1 to 2, right? And then you'd break your fingers and then you'd be done, right? We don't need broken fingers, right? So, but right, because the thumb has to be pointed towards wherever 4 is. Okay, if 4 is pointed over here, right? Your thumbs have to be pointed that way. Okay, if it's pointed down, well then if 4 is pointed down like this, well then your thumbs have to be pointed down. Okay, you just sort of see how you rotate 1, 2, 3, 1, 2, 3. Okay, but the nice thing is you don't have to rewrite the molecule. You just have to rotate your wrist. Okay, it's out here so you can sort of move this over here so you can see a little better. Okay. So for here, right, if your thumb is pointed here, right, so 1 to 2 to 3. You can always turn, when in doubt, you can always turn the page, right? So here the thumb was pointed out at you, so it goes 1 to 2 to 3. 1 to 2 to 3. Okay. Okay, so here we go. Okay, so you have this molecule. Oops. That's a wedge behind, CH2, CH2, CH3. This is a wedge, CH2, CH3. Okay, now on the exam I always point out where it is. In this case it's right there. I just forgot to put the arrow. Okay, so here it is. Okay, so now we're radiating away from it, right? So we're comparing the fluorine, the hydrogen, the carbon, and the carbon. Okay, so here the heaviest atom is going to be the fluorine, so that's going to be number 1. Okay, chlorine or the carbons become next. We don't know which one's 2 or 3, but we do know that the hydrogen is going to be number 4. Okay. Okay, so now here we have a tie, right? So now we're going to have to look at bonds, right? So we're going to look at here, so there versus there, right? So this one has, right? So there's a carbon-carbon bond there, carbon-carbon. So it has 2 carbon-carbon bonds. 2 carbon hydrogens, right? So this one is bonded to here, that carbon and that carbon, so it's 2 carbon-carbon bonds and has 2 hydrogens on it. Here, again, it's carbon-carbon bond right there, right? So it's 2 carbon-carbon, 2 carbon hydrogen, right? And there's a tie between those 2. So now what do? We go out one more, right? So we go there versus there. So we're looking at that carbon. Here, right, it's bonded, it has that carbon group and that carbon group, so it still has 2 carbon-carbon bonds, 2 carbon hydrogens, but this one here only has that 1 carbon-carbon group, 3 carbon hydrogen, right? So they still have the heaviest bond, still carbon-carbon, but this one has 2, while this one has only 1. So that means that this is going to be number 2, and this one's going to be number 3. Okay. So usually what I do is I go in and I redraw this with just the numbers, because there's usually ends up being a lot of writing on here. Okay. So this ends up being number 1. Number 3, number 2, number 4. Okay. Now, if you're doing the steering wheel method, so let's say that the red is number 1. Okay. The 3 is coming at you, so that's the blue. The green is going behind, so that's 2, and then the 4 is over here. Okay. So what we're going to need to do is we're going to need to rotate this like this, and so it ends up being. So this rotates over there, this one comes forward, okay, so it ends up, this is 3, 2, 1, and then the 4 is behind, okay, so, right, so it goes from here, it's rotating, 3 is rotating over here, and 2 is coming up, at you, and so it ends up being here. And so you look at it 1 like this, okay? 4 is going behind, right? So you end up being, so you get it like this, and so it's clockwise, so it's R. Okay. Now, if you can do the thumb method, the thing is the thumb has to be pointed this way, right? So you have to go. Your thumbs have to be pointed that way. Okay. And so it goes 1, and then 2 is behind, and then 3 is out here. And so you're going to need your thumb to point that way, and you start up here where 1 is. 2 is behind, so it goes 1, 2, and then 3 is back here. If you can get to just 1 to 2, that's fine. 1 to 2. 2 is behind the paper, right? So 1 to 2. If I try to do it with my left hand, right? So with that, so the thumb would have to be this way. 1 would be up here. When I tried to, get my hand to go back to 2 like this, I'd break my hand. Okay, so with that. So again, don't forget you can rotate them all. If it's easier, rotate the paper so it's a little bit more comfortable. Okay, so you can do it here. So it's 1 to 2 like this. Okay, you rotate the paper, something like that. So you end up using your right hand I forgot to mention this. When you use your right hand, when they sweep like your right hand, it's R. When you sweep with your left hand, it's S. Okay, so right for R, your left for S. Okay, so this ends up being R. Okay, so R. Okay, so for here, right? So this one here. Okay, so we have CH2OH. Shut the door. Okay, so for here, right, we're interested in that molecule there, okay, or that carbon there. So it ends up being, right, so that's a carbon, that's a carbon, that's a hydrogen, that's a deuterium. Now, deuterium is a heavy hydrogen, okay, stuff like that. So stuff like that. So for here, the carbons are going to be the highest. Okay. Here, deuterium is heavy hydrogen, right? So that's going to have a higher priority than that. So this ends up being 3, and this ends up being 4. Okay. So since this is carbons are a tie, right? We're going to take a look at the bonds, right? So for here, right, this has 2 carbon-carbon bonds, right? So 1 here and 1 here, and 2 carbon-oxygen, right? So 1, 2. Here, we have 1 carbon-carbon, 1 carbon-oxygen, right, and 2 carbon-hydrogen bonds. Okay, so we're going to look at the heaviest bond, which is the carbon-oxygen. This one has 2, and this one only has 1, so that makes this the number 1 priority, and that's the number 2. Okay, so it ends up being 3, 4. So 1, 2, 3, 4. Okay. Okay. So here we work out pretty well, right? Because 4 just so happened to be behind, right? So you can go look at this way. So the Sturdy method is all set up. So if you look at it going counterclockwise, it's S. So for the hand method, right? So you're going, your hand has to be going behind. Okay. Oh, that's why it's doing auto save. Okay. So your fingertips have to be going up top, right? And you sweep with your. You could sweep. Remember, your thumb has to be pointed down, right? Because that's where 4 is. So you sweep 1 to 2 to 3, right? If you can just get 1 to 2, you're fine. 1 to 2, right? So 1 was here, 2 is over here, so for that. So you sweep 1 to 2. And since you're sweeping with your left hand, it's R. If you tried to start 1 with your thumb down up here and tried to sweep this way with your right hand, you'd break your fingers. That's not good. Since you can naturally sweep, like close your fist, right, 1 to 2 with your left hand, that makes this S. Okay. Okay, last one. This is kind of a big one, so we're going to use this paper. Yeah. Okay. So this is our carbone, or excuse me, this is not carbone. This is well, we'll see in a second. Limonene, excuse me. Okay, so it looks like this. Okay, so the chiral center we're interested in is actually right there. Okay. Now you notice that we only see 3 bonds, right? So but we have a regular bond, dash. So that means that the hydrogen, the 4th bond, which we didn't have to show, is the hydrogen is on a wedge. Okay, because most bonds are going to be normal, dash, and it's a wedge. Okay, so we're radiating out, so we have a hydrogen, carbon, carbon, carbon. Okay, so these three carbons tie, but we do know that this one is going to be number 4. Okay. Okay, so since it's a tie, we need to look at these, right? So this one, 2 bonds shown, so it's hydrogen, hydrogen. Right, 2 bonds shown, so it's a CH2. Here, there's 1, 2, 3, 4 bonds shown, so there's no hydrogens, right? So we look here, right? So this would be 4 carbon-carbon bonds versus this one here, which is 2 carbon-carbon bonds and 2 carbon hydrogens. Here, again, it's 2 carbon-carbon, 2 carbon hydrogens, right? So again, carbon, the carbon-carbons are the heaviest bonds, but this one has 4, while these two only have 2. So that makes this side, the number 1 priority. But since this is the tie, what we have to do is we have to go one further out. Okay, so now we're going to compare that versus that. Now we're going to compare those two, right? 3 bonds are shown here, so there's a hydrogen here, right? So there's 3 carbon-carbon bonds, 1, 2, 3, 1 carbon hydrogen. Right there. Here, right, there's 2 bonds shown, so that means the other 2 have to be hydrogen. So there's 2 carbon-carbon versus 2 carbon-hydrogen, right? And since you're looking at the heaviest bond, this carbon-carbon for both of them, but this one has 3, this one only has 2. So that means this side has a higher priority than that side. So this ends up being 3, and this ends up being, ends up being 2, and this ends up being 3, because that 4 is there, right? So if we rewrite this as this. Okay, so this ends up being 4, that's 1, that's 2, that's 3, okay? So now here, the problem with the steering wheel method is the 4 is coming out at you, okay? So here, it's looking like this. So what we need to do is we need to be able to rotate this, okay, so that the 4 is going back. And when you do that, the 1 and the 4 end up flipping. Okay. 1, okay, and then but so did the 2 and the 3. The 2 and the 3 end up flipping as well. Oop, I'm doing so hot here. Okay. Okay, so now, right, so we're rotating counterclockwise like that, so it would end up being S. Okay. Now, if you did the steering wheel, if you did your hand method, right, now your thumbs are going to have to be pointed up at you, and here's where rotating the paper is going to help. Okay. And so for here, what's going to end up happening is 4 is going to out you, right? So 1 is here, 2 is over here. So, right? So, man, hold on. Did I do that right? Yeah, no, I'm sorry. That's, I don't know what I'm thinking. That's clockwise. So it's R. That's what I thought it was. 1 to 2, right? So 1 to 2, like that. So 1, 2, 3. Okay, sorry about that. So yes, so you end up, your thumbs are pointing, right? So if I tried to do it with my right hand, it would go 1 to 2, right? It's going to break your hand. But with your right hand, it's natural to close your hand 1 to 2 to 3, like that, because your thumb has to be pointed up. Okay, so like that. So again, it's R. So this is the R limonene. This one actually, this enantiomer smells like lemons. The S limonene actually smells like pine. Go figure. Like that. So, okay. Okay, so when you're naming these things, okay, what you want to do is you want to say, okay, if I have multiple chiral centers in here, if I only have one, I can just write it out front. If there's one chiral center, right, we know that the one chiral center, you put it out, you name it normally, and then with the chiral center, you just put either R or S out front. If there's multiple chiral centers, now you're going to have to list each one. So at the 3 position, so here, like at the 3 position, we figured out that that's R. At the 4 position, we figured out that it's S, in fact. And here, it's also S. So we're going to say 3R, 4S, 5S, and then the rest, the regular name. Okay, so that's just the regular name. But to indicate that there's actually how the stereocenters are oriented, you gotta put them out front of here. Okay, so for here, there's only the one stereocenter, so it ends up being just R, because that's the only place it could be. Right here, you have to list it, which one is which. Okay, you just put them in. Like 3, put them in, list them in numerical order, 3R, 4S, 5S. Okay? Okay, so now, to go from a name to a structure, okay, I'm not going to test you on this, but it's come into the homework, and it definitely comes up on like the ACS final. It comes up on the GRE. It comes up on the MCAT, but it just takes too long to do it during an hour-long test. Okay, the trick to this is that it's sometimes easier to go ahead and do the RS to figure it out than it is to try to go in and work it and stuff like that. So what you want to do is just draw the structure as normal, like without any wedge and dashes, and then just pick a wedge and a dash to put in. Okay, it doesn't matter how you do it, because then what you do is you do an R and an S. Then you figure out if you got the R or the S correct, with how you drew it. If you got it correct, great. If not, what you do is you then switch. All you have to do is switch the wedge and dash. That's all you got to do. Okay, it's because you're then switching the enantiomers, right? So like that. So if you have this molecule here, so if you want to say draw S2-chloropentene, okay, you just start off with just drawing 2-chloropentene, okay, and then you say, well, let's put this as a wedge, right? Because if we put this as a wedge, right, well, we're automatically set up, right, with this hydrogen to be in the steering wheel method, right? So like that, because that's going to be the 4. This is going to be 4 with the hydrogen, right? And so that's automatically set up for the steering wheel method. Okay, so here we have CH3, CH2, right? So for here, well, the chlorine is definitely going to be heavier than this, so that's definitely going to be 1. Here it's right, it's 1 carbon-carbon bond, 3 carbon hydrogen. Right here, right, because we're radiating out from that chiral center there, 2 carbon-carbon versus 3 carbon hydrogen. Oop, carbon hydrogen. Carbon hydrogen. All right, so this is going to have more carbon-carbon bonds on this side. So this is going to get a higher priority than that. Okay, so so it's going to look. Oop, it's going to be 1, 4. But notice how if we draw it like this, we're automatically set up to do the steering wheel method. 3, 2. Well, we did here, and we've drawn the R. We've drawn R S2-chloropentene. So, but here we go. See, that didn't take hardly any time at all, right? So to figure this out, all you got to do is just say, okay, well, let's just switch the wedges and dashes. Ta-da! There you go. You've got your S version. If you know that that's R, then to make the S, you just switch the wedge and dash. That's all you do. Stuff like that. So just draw it out, figure out what it is. Draw it one way, figure out you got it right. If you got it right, great. If not, just switch the wedge and dash. No big deal. So that usually ends up being about the easiest way to do it. Sort of a brute force, but that's it seems to work. Okay. Now the other way that you can do the other isomer that we're going to talk about this is for alkenes. Okay. So we've talked about this before with cis and trans. Okay. The easiest way to look at these is to look at the how the hydrogens are pointing. So for cis, the hydrogens are going to be pointing away from the double bond the same way. So right, so they're both pointed down away from the double bond. Here, this one's pointing down, this one's pointing up. Okay, and stuff like that. So, but the problem comes: what happens if you don't? Let's say that's a bromine. Well, how are you going to pick that out? Or let's say those are both bromines, right? What are we going to do, right? So with cis and trans, you have to have a hydrogen on both sides of that double bond. But if you don't have that, well, then what happens? Okay, that's where what's called E and Z come into play. And so what you do is you take a double bond, okay, and what you do is you slice it down like that, okay, stuff like that, so that and stuff like that, and so you're checking out what's hanging off of this carbon of the double bond and this carbon of the double bond, okay, and then what you do is you cover up one side and you do those Engel-Prelog rules, okay, just like we had in the R and the S, but you set which is the higher priority and which is the lower priority, okay, and so and then you cover up so you do that, and then you reset yourself and now cover up this side and do the same thing. You take your hand away and you say where are the higher priority things, okay? If they're on the same side, okay, that's we call that the Z configuration, okay, and this comes from German, okay, for zusammen, which is together, okay. I think that's how you say it. German's really bad, but the easiest way to remember is that they are on the same side. You got to do this really bad German accent, right? My German great grandmother is rolling in her grave. All right, so they're on the same side, right? Stuff like that. So then there's Z. Okay. If they're on the opposite sides, okay, then we call that's again, my German's bad, but I think you pronounce it entgegen. It means opposite. Okay, and so they're on the opposite sides. Okay, and so here you represent it by E. Now it makes German, so that it just so happens that if you look at the letter, it's the opposite of what the letters are doing, right? So for the Z, the top and the bottom sort of things are pointed opposite. So you would think that would be like a transverse, right? They're on different sides, but they're not. It's together. Here, E, like those top and the bottom, they're sort of pointed at the same direction, but in fact, it's saying more like it's saying more trans. It's opposite of what the letters are doing for this. Go figure. Stuff like that. So again, if they're on opposite sides, it's E. If they're on the same side, if the higher things are on the same side, it's Z. Okay, so there we go. Okay, so for this one, okay, so here we go. Okay, so you slice it like this. Okay, so here we go. So you're going to cover up one side and you say, okay, we have a hydrogen versus a carbon. Okay, so carbon's heavier than hydrogen, right? So this wins. So this is going to be high. This is going to be low. Okay, on this side, right, so then we cover up this side and we say, okay, we're looking at chlorine versus a carbon. Okay, so the chlorine is heavier than the carbon, right? So, well, this is going to be the high, and this is going to be the low, right? So we take a look at this. Well, the highs are on opposite side, right? So they're opposite sides, so that's E. So this is the E configuration. Okay. So if we look at this one, and again, if you had a tie, right? So just like the R and the S, you would go out one further, and you keep going until you can make that distinction. Which one's higher? No, just like R and S, you would just keep going out until you find a difference. Okay, so this one is like that. Okay, so for here, right? So we're talking about. All right, so remember you got to split this in half like this. So you're looking at this carbon, what's hanging off that carbon, and then you're looking at what's happening on that carbon. Okay, so here, right, they're both carbons hanging off here, but that one, right, it's a CH3 group, right? So there's one carbon-carbon versus 3 carbon-hydrogen. Here, you're talking about 2 carbon-carbon and 2 carbon-hydrogen, right? So 1 carbon-carbon versus 2 carbon-carbon, right? So that means that this is going to be your high, this is going to be your low, okay? So then we cover up this side, right? So for here, that versus that, right? So for here, you're talking about 2 carbon-carbon, right? There's 2 bonds shown, so there's 2 carbon-hydrogen. Here, there's only 1 carbon-carbon, but there's also this carbon-oxygen bond, and 2 carbon-hydrogens, right? We're looking at carbon-oxygen versus carbon-carbon, right? So this is, even though this is 2, it doesn't matter. This is still heavier, so that makes this the high, and this is the low side, okay? But since the highs are on the same side, it's Z, okay? So there we go. Now again, with the naming, right? So with that, it's going to be very similar to the to how you would do it with the R and the S. What you do is you just, if there's one, or if you only have to list one E or Z, you just put out front. You don't have to worry about it. Okay. If there's more than one, you have to tell where those are. Okay. Like at the 1 position, it's in the E configuration. At the 3 positions, right? So if it goes 1, 2, 3, 4, 5, right? At the 3 position, it's going into the Z configuration. Now, if you notice here, there's 2 double bonds, right? So, right. So there's 2 double bonds, right? But I didn't list which one it is. The reason why is because if you look at where the 1 is, okay, if you were to try to do this as a high and low, well, you're going to compare hydrogen and hydrogen. There's no difference, right? It's a tie. So therefore, when there's a tie, there's never going to be a there's never going to be the what is it? An E or a Z. Oh. There we go. Sorry if that was blurry. I don't know what the heck this thing's doing today. Okay. If there's an E, if there's a right? If there's a tie on this side, then there can't be an E and a Z. So this E refers to this double bond there, okay, in the 3 position. Okay, so naming the structure, it's again, you do it the same way. If you go from a name to a structure, you just draw it in some form. If you get it wrong, you basically what you do is you take one of the sides of the double bond and flip it. You hold the other one fixed and you flip it, and then that's automatically, you automatically flip this the side of the E of the high, and so you flip it their way, right? So if you have E2-chloro-2-pentene, right, so it's easier to just go ahead and draw it like that. So it's your sawtooth. Okay, so again, you're going to slice it like that. Okay, so here you've got a chlorine versus a CH3, right? So it's a carbon, right? So this is going to be high, this is going to be low. Okay, now here, right, this 3 bond shown, so that means that there's a hydrogen here, okay, for that 4th bond. So you're comparing carbon versus hydrogen, right? So again, you're going to have high on this side, low on this side, right? So here, the highs are on the same side. Okay, so this is actually the Z version. Okay, so what you do is you hold one of those fixed and you rotate it. Okay, so, right, so here, right, so we're going to hold this side fixed and flip this. Okay, so now this is automatically the E version. So this is the one we want. It doesn't matter which side you do. So here I held this side fixed and then flipped that. It doesn't matter which side because you just take and flip it like that. So, so there you go. Good luck.